Hey everybody, Brian here from quantlabs.net. I'm going to show you the first step into this older but newer 2015 edition of this workflow that I now call Best Workflow to HFT. So basically the three steps involved are using Mupad, which is Matlab's internal editor for expressions, mathematical expressions using scientific notation. That's where you implement your algorithm scientifically via that notation. I sound like a mathematician here. And then be able to convert that algorithm or equation into a Matlab M function. So here you have the listing here available for basically having a Matlab function, but creating, as I said, a Matlab M function from these Mupad expressions. So I'm going to show you how to do that. So I'm just going to do exactly what this tutorial explains. There's two options you can use. You can use from the Mupad variables. Now I think this is new because I've never seen this other methodology in later versions of Mupad and Matlab. So I'm going to focus on this option, which is easier. So basically what we're going to do is we're going to load in a expression in the Mupad language, which is essentially for your scientific notation, and then be able to convert it into a Matlab function using this right here from within Mupad, and then you'll get this function. Okay, so let's hop in. Now I'm using Matlab 2015A, its current version. And what I've got here is I've got my Mupad editor, and what we need to do first, we need to essentially load in our Mupad session within Matlab. So what we do is we just can do this. We create a handle and load in our Mupad editor. So whatever is created in that session is returned back into the Matlab workspace. Now if you're new to Matlab, let me just show you the difference here. This is a Matlab workspace. All this is the workspace of Matlab. There's other environments within Matlab that you think is part of Matlab, kind of is, but it's not. Simulink itself is its own workspace. The Mupad is its own separate Mupad workspace as well. So the Mupad is its own product within Matlab, and this is part of the math toolbox, symbolic math toolbox. This is one of the big benefits of it. This is what it looks like, this Mupad right here. So let's say if you continuing along after stupid errors, wonderful things about new technology that you jump back to you haven't looked at in a while. Anyways, so what we got here is we got the code from Mupad. As I said, no different than this stuff here, right here. It's identical. And what we're doing is we need to evaluate this set of code in Mupad. So we've done that. So what does it look like? So we'll just enter in the result, which is S. So this is our new equation. This is our actual scientific notation I'm referring to, and this is the value of S, which is a combination of all these other expressions, I guess. So if I go in here and I want to now create a, like I said, I'm using the second option. There's this first option. There's this option where you generate MATLAB code in a Mupad notebook. So I'm right now in a notebook session. We just add this line into the Mupad. One thing you need to know about Mupad itself, instead of what we may be used to using a semicolon to end a line in Mupad, it's actually a colon. So what can throw you off? So let me just show you how to do this Matlab function. So I've already got a Cartesian function already. So I'm going to rename this just to Cartesian 2. Okay. So off it goes, and there is our Cartesian to MATLAB M function. So if I load it up, this is what it looks like, exactly what you would get from Mupad itself. But as this document explains, it does convert the code from Mupad, as you can see, but you now need to define the MATLAB. This is just a MATLAB script, so you have to define it as a function. So that's really easy. All you got to do is just come up here and add function, whatever you want to call it, s equals. Now you got to make sure that your function name matches the file name itself. Like, pretty obvious. And that's all we need to do. So we have to add in the arguments as well. So we're going to add an RAB. Just clean it up a little bit and put an end at the end to close off the function. And that's it. We save it. So now we can run our Cartesian to any difference. So if I go 1, 2, 3, we'll call it s equals. There you go. So that's the value now of the Cartesian function. So that's how you can now define a function, a MATLAB M function from your Mupad symbolic expression. So this essentially could be a big algorithm that you would typically get in a book, a research paper, or talking to people, or even in your own head. This is how you do it and how you convert it into a MATLAB M function. This is really powerful now. So now, next step is to take this MATLAB function and drop it into a Simulink model. I'm going to do some other little demos of the Simulink itself, and then show you how you can generate C, C++, and HTML for both Xilinx or Altera FPGA boards. And that, my friends, is how you get to HFT very quickly and very rapidly using this tool, Mupad, via also your custom M function. So this is your first step. Hopefully you like it. Talk to you later.